This video, we are going to graph quadratic functions using the Vertex, axis symmetry, and intercepts. So we are not going to complete the square this time. Number 19, we have x squared minus 6x, what y equals. So we have negative b over 2a. It's going to be 6 over 2 is 3. And for our k value, 3 squared minus 6 times 3 is 9 minus 18 is a negative 9. If we factor this is x times x minus 6. If I set that equal to 0, means x equals 0 or x equals 6. So that means that I have x-intercepts at 0, 0, and at 6, 0. I'm also going to have a y-intercept at 0, 0. If I let x be equal to 0, the constant over here is y is 0. So that's going to give me 0 for my y-intercept. Let's use those points to try and sketch a graph of this function here. So we have the point 0, 0. We have the point 6, 0. We have the point 3, negative 9. 3, 8. So looks like this is going to be negative 9. Could be not quite halfway there, like so. And it's a little thicker than I would want right now. Let me see if I can change that. There we go. Try this again. 6, 0, 0, 0, and at 3, and it was somewhere right down around here, and the vertex, and it's going to go like that. This one is looking a little strange because the x-axis and y-axis are not to the same scale. You see that this one is going all the way up to 40 and negative 40 on the y, and it's only going to negative 10 and 10 on the x. So that's why we're getting some distortion there. So I'm going to focus more, again, on the calculations than on the graphing part here. I'm going to let you graph them in your calculator or on Desmos if you would like. We've got f of x is equal to the negative x squared minus 8x formula. Again, we have a plus 0. Our y-intercept is therefore going to be at 0, 0. Factor out a negative 1. Factor out our x. X equals 0 or x equals negative 8. Our x-intercepts. Going to use our vertex form of our parabola. and have a positive 16 here. So our vertex is at -4, 16. -4, 16 is somewhere right there. Our x-intercepts are at 0, 0, and at -8, 0. There we go, right there. And yep. And our axis of symmetry is right here at x equals -4. I didn't graph that last time, but we should see that the x-intercepts are equidistant off of that. If I want to find an additional point, such as when x equals to -1, it's being -1 plus 8, 7. So 4, 8, 7 is right about there. Then there would be something that would be over here. That would be symmetric to that. That's the idea of getting the axis of symmetry, is so that you can use the fact that it's symmetric to plot the points that are on the other side. So something like that. Okay. Now have f of x equal to x squared plus 8x plus 16. This is a perfect square trinomial. X, doing it that way though. This is, well, we are going to need to factor it. So yes, we are. This is x plus 4 times x plus 4, which makes this x plus 4 squared. So my x-intercepts are at -4. Remember, this is a multiplicity of 2. So may not have gotten to this point yet in pre-calculus, but if we have an even multiplicity for our x-intercepts, it means it's going to touch and not cross. Want to see that there? So this is going to touch, not cross. Our y-intercept is going to be at 0, 16. So 0, 16 is there. We have -4, 0, and it's going to touch, not cross. Our axis of symmetry is at -4. So that means that if I go 4 to the left, 5, 6, 7, 8, I'll also have a y value of 16 over here. And I can use that symmetry to form my parabola. Again, I'm not the best at drawing, but you can get better graphs with Desmos or your graphing calculator. X squared plus 8x plus 7. If we factor that, that's x plus 1 times x plus 7. Set it equal to 0. X plus 1 equals 0, or x plus 7 equals 0. X equals -1, or x equals -7. 7. There's -1. We know that when x equals 0, we have 0.07. 5, 6, 7 is there. our axis of symmetry, x equals negative b over 2a, negative b over 2a is a negative 8 over 2 is a negative 4. So our axis of symmetry is here. Our vertex lies on that axis of symmetry. So negative 9 is down here. And we get another point that is 1, 2, 3, 4 to the right, 1, 2, 3, 4 to the left. We're up here at 7. We get a nice parabolic shape. Again, my stuff that I've got here is meant for writing numbers and letters, not so much for drawing shapes like that. So let's go ahead now and deal with f of x equal to a negative x squared minus 8x minus 7. Factor out the negative 1 first. Then we have x plus 1 times x plus 7. And that means that x plus 1 equals 0 or x plus 7 equals 0. X equals a negative 1 or x equals a negative 7. There's negative 1. There's negative 7. Negative b over 2a. It's going to be a negative 4 again. So our axis of symmetry is somewhere like so. So this is a very similar problem to the last one, only it's up here at a positive 9 now. On the axis of symmetry there. And our y-intercept is at negative 7 down here. And so that means that we have another point that's symmetric to it over here. This one's going to open down because the leading coefficient is negative. And it's going to go kind of like so. Again, these are just sketches, not perfect graphs. It's going to factor into x minus 5 and x plus 1. And we set that equal to 0. It's going to give us that x minus 5 equals 0 or x plus 1 equals 0. X is going to be equal to 5 or x is going to be a negative 1. Know that our y-intercept is going to be 0, negative 5. Negative b over 2a. Going to give us a x value of 2 for our vertex. And when we calculate the y value, get a negative 9. So 2, -9. Their vertex means that our axis of symmetry is on x is equal to 2. We've got a y-intercept at 0, -5. We've got x-intercepts at 5, 0, and at -1, 0. And that means that there's a reflection over here, like so. That makes a parabola kind of like so. For number 25, f of x is equal to -x squared plus 8x minus 7. Factor out that -1. X minus 1, x minus 7. Set that equal to 0. X minus 1 equals 0, or x minus 7 equals 0. X equals 1, or x equals 7. My y-intercept is going to be at 0, -7. Remember, this one is going to open down. It's got a negative leading coefficient. 0, -7 for my y-intercept. My x-intercepts are at x equals 1 and x equals 7. My x-coordinate of my vertex is at -b over 2a. Is that x equals positive 4 when x is 4. Y is 9. So 4, 9. Right there, and that puts my axis of symmetry at x equals 4. That puts this point that is 4 to the right at the same y coordinate over here. And that gives me a parabola that looks like so. I think I've just got one or two more. Okay. So factors of 103, not divisible by 2, not divisible by 3, not divisible by 4, 5, 6, maybe, nope, not 7, not 8, not 9, not 10. So I don't think 11 is going to work. So I think maybe that might be a prime number. Pretty sure that this is going to be a case where completing the square is going to be the best way to help me. Let's check it out here. Not always the right way, but half of this number squared is 25. When I subtract that, I'm subtracting 100. X plus 5 squared plus 3, okay, is going to mean that my vertex is at -5, 3. My intercepts here are going to be probably irrational numbers, is why I was having a hard time trying to factor that. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So we might get a negative 40 plus or minus the square root of 40 squared is 1600 minus 4 times 103. We're going to get a number bigger than 1600 there. So there's no solution here, no real solution, no real x-intercepts, no real zeros, excuse me. So there's no x-intercepts. All right. Our y-intercept is way up here off the charts. So our axis of symmetry is at x equals to -5. We have -5, 3 there. And we have a multiplier of 4. So when I go 1 to the right, I'm going to go 4 up. 1, 2, 3, 4. This is off of old techniques from a previous video. -1, 4. So this has been stretched a lot. We're just going to go up really fast like that, so that by the time that we get to x equals 0, we're way up here at 103. I didn't have a better way to graph that one that time, so we resorted to completing the square, and the intercepts weren't really going to help us that time. F of x is equal to -10x squared minus 2x minus 5. So let's see if I can get my x coordinate and my vertex. -b over 2a is -1/10. -10, -2, -5. It's going to give me a +1, -1. Then it's going to give me +1/10 as a -49 tenths, or -4.9. So we have a -1/10, almost -5 down here for my vertex. It's down there somewhere. Let's see if I can find some x-intercepts. So -b plus or minus the square root of b squared minus 4ac all over 2a. I got a problem here that I've got 3 negatives. So there's going to be no x-intercepts. Going to be opening down from this vertex. It's got an a value of 10. So when I go right 1, I'm going to go down 10. It's way down there. When I go left 1, I'm going to go down 10. It's going to be down there. And got something that looks kind of like that. Again, Desmos is going to do a much better job graphing that. All right. And we will come back next time and go from a graph to writing the equation of that graph. So look forward to that next time. See you then.